What's going on, guys? In this video we are going to see an example on Norton's theorem. Norton's theorem is basically when we have a linear circuit like this, we can bring that one into a simple Norton circuit with one I Norton and R Norton, also with a load resistance, and also we can find out the current across this load resistance. And let's see how we can find out R Norton and I Norton. That's the main thing. Now to find the R Norton, we use the same approaches as R Thevenin. If you remember R Thevenin, that when we try to find R Thevenin, what we do is we remove the current source and we short circuit the voltage source and solve for the resistance. And that's what we did right here, right? We removed this current source 2 ampere and we short circuited this 8 volt. So we remove that one and put it as single line. And then we solve for this resistance, that is 8, 16. Both of them are in series, so we added them together and we got 24 ohm. And to find the I Norton, what we do is we connect this A and B terminal and we find the current across this one using mesh analysis or whatever the method easy according to the situation. Here it's mesh analysis is easy. But here what I'm going to do is I'm going to use an alternative method to find out this I Norton. Because there's an equation that is I Norton is equal to V Thevenin over R Thevenin. We found out R Thevenin, that is 24 ohm, because R Norton is equal to R Thevenin, right? So that is equal. Now we have to figure out what is V Thevenin is. V Thevenin, if you remember that we find out the voltage across this terminal, and that's going to be the V Thevenin. Now let's go ahead and draw this circuit again. So this is going to be 2 ampere, and here we have 8 ohm resistance, and also we have a voltage source, and we have 16 ohm, and this is A, and then this is B. Okay, so now let's call this node, at this node let's call the voltage is V1 and the voltage across this one is V Thevenin. That's what we are trying to find. And since we don't have any current flow right here, this V1 is going to be equivalent to V Thevenin, right? Now let's see how we can find out this V1. Now we know that this current is going toward this node, so we can put the current direction like this, I1, and also this is plus, this plus is right here, so this current also going toward this, and let's assume this current is going toward this, and that's it, right? That's it for this one. Now we can add them together. Sigma I should be equal to 0, right? So I1 plus I2 plus I3 should be equal to 0, and let's plug the values. So first of all, I1, that is we know that 2 ampere, and I2 is going to be high voltage minus low voltage. So this is 8 voltage actually, 8 voltage. So 8 minus V1 over the resistance in between, that's going to be 8. And I3, we don't have any current flow in this one, right? So that's going to be just 0. And that's equal to 0. And let's solve for the V1. Now we can take 8 as common denominator, and that's going to give us, or we can multiply everything by 8. Both way it will work. And if we multiply everything by 8, this is going to be 16 plus 8 minus V1 is equal to 0. Therefore V1 is going to be equal to 24 voltage. So since V1 is 24 voltage and we don't have any current flow across this one, so at the V Thevenin is at this location, so this should be equal to V1, right? So this is also equal to V Thevenin. Now we found out the V Thevenin, so we can solve for this I Norton. So I Norton is going to be just V Thevenin over R Thevenin. V Thevenin we found out 24 voltage, and then R Thevenin was 24 ohm. Therefore I Norton is going to be 1 ampere. Now we found out the I Norton, and also since we have I Norton, we can find out the current across the load resistance. That is given by this equation. Now let's write that one right here. IL So this is current across this load resistance, that is equivalent to 1 ampere, that is our I Norton, times R Norton, that is 24 ohm, over R Norton, that is 24 ohm, plus R load resistance, that is whatever the value we have for load resistance, right? So we can leave it as generic pattern like this, and that's how we do this kind of problems. I hope this helps. Thanks for watching.